You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey, everybody. Welcome back. Welcome back to me. It's good to be here.
Victoria!
Yeah, we're happy to have you back.
Yeah,
Yay!
it's always good to be back. A few weeks ago, I was listening to a different podcast, Radio Lab, in fact.
Oh, yes. That's okay.
Fair.
Yeah.
Allowed. We'll allow it.
Yes. They were talking about an interesting question, which I believe was posed by the child of one of the hosts. So the question was, in the human body, are there 3 of anything? So that is, we have one head, one heart, one anus, one uterus. We have 2 of a lot of things, lungs, eyeballs, brain, hemispheres, gonads, kidneys.
Right.
We have 4 limbs. We have 5 fingers on each hand and 5 toes on each foot. But do we have 3 of anything?
2 types
being
of
bilaterally
bones.
symmetrical,
Right.
that would be odd.
Well,
3
so
of
they
them.
had to rack their brains and talk to numerous scientists before coming up with an answer. There are 3 valves of the heart that have 3 flaps each.
Oh,
okay.
Yeah.
Yeah,
That is very particular.
That's a cool one.
kind of cool. And the reason this is so hard to figure out, and the reason that this is the only example, is, of course, that, as you mentioned, Kirk, the human body is bilaterally symmetrical. This is also the case for all other vertebrates. And so what that means is that the left half of our body is more or less the mirror image of the right half.
Yeah,
Which
pretty
I feel
much.
like makes it's easier to follow that sort of plan, right? Like when you're developing things. You have to
It has some
come up with
evolutionary
something
advantages,
twice.
for sure, which
Absolutely, yeah.
is why this is true, in fact, of almost all animals, including insects, arachnids, crustaceans, mollusks, and worms. Those are all bilaterally symmetrical. Of course, no one is entirely symmetrical on the outside, and our internal organs are not symmetrical for the most part. For example, in humans, our hearts famously lie on the left side of our chests and are tilted.
We are not Time Lords. That's an important
No, we are
distinction.
not Time Lords. Our liver and our gallbladder are on the right, our stomach and our spleen are on the left, and so forth. So, for the purposes of this podcast, I'm going to be talking about symmetry in terms of general body plan. So, for example, even though a fiddler crab has one front claw that is much larger than the other front claw, its general body plan is still bilaterally symmetrical, so that still counts. Okay?
Gotcha.
There are a few animals that are not bilaterally symmetrical. So, most notably, cnidarians, if that's how you pronounce that, such as sea jellies, otherwise known as jellyfish,
Okay.
corals, sea anemones. Those are radially symmetrical, which means that they show repetition.
That rings a bell.
Yeah, they show repetition around a central point or
Terrible.
axis of their body. So you sort of think of the way a cake or a pie is symmetrical. You take a wedge out and it looks the same as every other wedge.
Sure.
Yeah, if you get there are 8 raspberries around the edge of your cake and you cut a slice with 8 slices with a raspberry in the middle of each one. Echinoderms, such as sea stars and sea urchins, are a bit different because they are actually bilaterally symmetrical as larvae, but as adults they have a 5-fold radial symmetry. Like if you've ever seen like the typical sea star, right? Or if you've ever seen a sand dollar, which are those round ones that have a little sort of 5-petaled flower shape in the middle. And finally, there is an animal that is actually asymmetrical, or type of animal. Most sponges are asymmetrical.
Okay.
Huh. Okay.
Yeah.
All right.
I guess there are a few that are radial symmetrical. So as you mentioned, Rachel, it is a useful feature in a lot of ways. So in particularly bodies that move, limbs are going to work together a lot better if they're paired.
Mm-hmm.
I spent a few moments after I wrote that thinking about how it would possibly work if your limbs were not paired.
Well, I mean, think
If you were
about
trying to walk
three-legged
around,
race, you know?
right?
Like
Yeah.
we struggle with that
Interesting, yeah.
because there's one in the middle and you're like trying to figure out the outside pair. You have to work up a rhythm rather than just
I mean, I
being
think you're
able
also
to do
struggling
it.
because you're not in control of all three of them. That's a
That's
big part of
also
it.
fair.
Yes.
Yes.
Yes. Symmetry also gives us backups of things. Like you can still live even if you lose one of your kidneys. And
Yep.
you can still
Mhm.
see somewhat even if you lose one eye.
Mm-hmm.
Right. Or hear with one ear, yeah.
Yeah, exactly. Symmetry is less important for organisms that are sessile, that is, that they don't move around. One of the reasons why it's okay for sponges to be asymmetrical is because they don't move.
Mm-hmm.
Fair.
But going back to that original thing I was discussing at the beginning of this episode, it is rare for there to be three of anything in animals.
Yeah.
And triradial symmetry. So if you think of like the Mercedes car symbol,
Mm-hmm.
that's triradially
Yep, I'm with ya.
symmetrical. That's something we pretty much never see in animals. So the heart valves I mentioned, yes. There are several species of leech that have, in a really freaky way, 3 jaws that are triradially symmetrical that they use
Oh,
to
I hate that.
bite you. Yeah,
knew
they
you
make a
would.
little Y-shaped incision in your skin using their 3 jaws.
Oh no.
Yeah.
Uh-uh.
And nematode worms actually also have a triradially symmetrical mouth and gut. Like if you do a cross section, there's
Why
kind
are
of
there
Okay.
tri-radial mouths of everything that there could be tri-radial of? Why does
That's
it have
just
to
like
be
nightmare
mouths?
fuel right there.
Yeah. Yeah, but all of these features that I just mentioned, they are in
no.
animals where the overall body plan is bilaterally symmetrical.
Sure.
So imagine my
Mhm.
surprise when I recently
Oh, boy.
came across a creature with a triradially symmetrical body plan.
Yes.
Their whole body.
Oh, I'm so excited.
Yeah, in fact, it's a whole group of creatures. So it would be
What?
probably pretty easy to have seen one of these if you'd been crawling around on the seafloor, say like 550 million years ago.
Okay, see, I was not doing that. I'm not quite that old.
No.
Yeah.
No.
Yeah, they were quite common for a certain period of time. They're called trilobozoa, and they are all extinct. Yeah.
Oh,
Ah,
I think if you break that Latin down, it means 3-lobed animal.
yeah. I
that
think that's
sounds
fair to say.
right.
yeah.
Actually, I was like, real creative name there.
Yeah, I mean, it's descriptive.
I love it when they make sense. I appreciate that.
It's good.
Better than the vomitorium holly. Anyway, these were animals.
Nice callback.
Yeah. They were roundish, sort of maybe hemispherical, shield-like sea creatures. So looking a bit, in fact, like a sand dollar, but mostly quite small. So between 3 and 40 millimeters wide.
Okay.
The most well-known one is called Tribrachidium. And it's really one of the most striking of these types of animals because the trifold pattern of its body is actually a triradial spiral. So instead of being like a Mercedes symbol, each
Really?
arm curves. It seems likely that these animals were filter feeders or possibly that they absorb nutrients through osmosis the way that fungi do today. But some Australian scientists have done some modeling that shows, some sort of fluid dynamic modeling that shows that perhaps the outside of their bodies would direct, that triradial shape would direct the water flow up to the apex of the animal. So up at the
interesting.
top,
Okay.
there's like a little
Okay.
depression and it creates a kind of a vortex there. And they think that there might have been some filter feeding structures up there so that the flow of water from the shape of their bodies actually aided how they would eat.
Cool.
Yeah. And,
Awesome.
as I mentioned, 550 million years ago, strangely enough, animals with this body plan only appear in what is known as the late Ediacaran era. So the Ediacaran era was from around 635 million years ago to 538.8 million years ago. And that was when the Cambrian begins, which is when like most of the life that we know from the fossil record and that we see on Earth today.
The Cambrian explosion.
Yeah, the Cambrian explosion that began then. And so the late part, the part closest to the Cambrian was when these triradial Trilobozoa appeared.
I mean, imagine if that had been really successful and continued, we might see that like everywhere on Earth then.
Exactly. But in fact, they seem to have completely died out by the end of that era and the beginning of the Cambrian. Yeah, and this was actually that era was the period when the first complex multicellular organisms developed, but very few of them had hard shells, so the fossil record's fairly sparse. And it's actually not just Trilobozoa. Most of these organisms have really strange body plans without any obvious descendants from later periods.
Wow. Yeah, there was a lot of experimentation going on, basically. Right?
Yeah. And in fact, some paleontologists think that most of these Ediacaran creatures left no descendants, died off, and possibly that later multicellular life evolved again kind of from single-celled organisms, so from scratch kind of.
Wow.
Yeah. And it seems pretty settled that the Trilobozoa were animals, but for a lot of these other creatures from that era, it's not even clear if they were animals, lichens, algae, fungi, protists, or some like weird intermediate plant-animal creatures. So there's a lot of scientific debate about this. It's kind of cool. But anyway, that's what I found. It just seemed so cool to me that there was this whole experimental body plan that appeared for some number of million years and then just gone. My sources this week were an article by Rockman et al. In Science Advances from November 2015, a blog post from Evolution News in March 2021 by Günter Beckley, the Encyclopedia Britannica, and Wikipedia.
Nice, thank you.
Yeah, we're going to take a little break, and when we come back, it'll be Kirk.
Hey, everybody, we're back. We always love hearing from our listeners, and we can't read like all the emails and messages that we get necessarily on the show, but we do appreciate when you write in. We read all those.
I have one that I'm keeping in my back pocket. We also hear from our listeners.
Oh, okay. Yes. So yes, sometimes people send us ideas and things, and sometimes they're directed to a specific person. I'll see an email and be like, nope, that's not for me. I'm not going to read that one. But I was going to say, we also hear from listeners in person. And that's really fun because there's people in our lives who, believe it or not, listen to our show. So it is fun to get some real-time reactions, usually from like our friends and coworkers. And one of those people is somebody that is known to our regular listeners. It's one of my coworkers. I don't know if you guys knew that he was a coworker of mine, but this is someone who listens to the show every Wednesday morning before coming to work. And that person is none other than occasional guest naturalist and our yearly quiz master, Mr. Brett W. Seaverer. Hello, Brett. So Brett often greets me on Wednesday mornings with questions or just to share his amazement at something one of us said. But a few weeks back, I was greeted in the kitchen at work in the morning, and I believe he just said something like, "How dare you, sir? How dare you?" And I'm like,
okay.
I've gotten that reaction.
That's not a
from
super
him
unusual
once,
reaction to get in the morning, but I was like, I'm like, what did I do? He's like, you know what you did. And I'm kind of going, what did I do? And he's like, the podcast. I'm like, oh, right. And you got to realize we record these a few in advance. So I'm racking my brain like, what did we do? Which one went live this morning? What was my topic? And then I realized why he was, saying this. My topic for the week was one of his least favorite topics of all time. And I got to tell you, as professional naturalists, we're not squeamish about much. Like, we literally poke weird things with a stick for a living.
It's so fun. So, if things are dead, you got to poke it with a stick.
Right. Now, there's one topic, though, that Brett seems to be unable to handle.
Okay.
And that's tapeworms.
Oh.
And I did talk about tapeworms just a few weeks back.
You know,
And
I don't blame him because I still am recovering from that.
oh, good. Me probably just mentioning it now probably has Brett like in his car or something going, okay. And by okay, he means not okay. Now, dear listeners, you have to understand that writing and producing a podcast like this does incredibly messed up things to your browser search history.
It's so
Things-
messed up.
Things that are
search history is
difficult to
awful.
undo. And the algorithm thinks it knows best what, fresh new scientific studies to serve up to me. And so it probably should not be a surprise where this week's story is going.
Oh, no.
goody.
So Brett and everyone else squeamish, consider yourself warned.
Oh, God.
Okay, deep breath.
Yeah,
Here we
you
go.
all could fast forward through Kirk. We're listening to it.
You have to listen.
We're trapped
An
here.
interesting case was published last month. That would be March 2024 in the American Journal of Case Reports. And I will point out that one of the tags that this article used that was tagged with was pretty amusing. It was tagged with challenging differential diagnosis,
Oh,
to
good.
which I would say, yeah, correct. That's an understatement. What that basically means is the doctors had no idea what was going on with this 52-year-old man who showed up at their office not feeling well. And it seemed like the biggest issue he was having was that his migraines were getting progressively worse. This is a guy who had suffered from migraines for years and years and years. But he was always able to get them under control. They were sort of an occasional thing. But something had clearly changed. These migraines he was getting were weekly migraines for the past 4 months,
That's
which
rough.
you can imagine must have been just horrifying. And also strangely, they did not seem to respond to any kind of medicine or any of the things that would normally stop his normal migraine. So he was like, something has changed. It's time to go in and see the doctor. The migraines seemed to be at the back of his head on both sides. And the doctor looked him over and noted that aside from his history of migraines, he was obese. He had type 2 diabetes. And they're trying to find like, what are all these different threads that could come together? So they look at the physical things that they knew. And once they had ruled that out, they started to go through questions, which is what you do to try to figure out like, have you been traveling anywhere recently, right? Could maybe you picked up some sort of a bacteria or virus or something. Asked about travel history. He had been in the Bahamas like 2 years ago, but they're like, it doesn't sound like it's probably that. Asked about his living situation. He lived in a nice modern home with access to good, clean food. He's not like homeless or anything or eating garbage. He did not frequent, street vendors or anything like that. He didn't eat raw food. And, hold on.
Kirk, if
now
this is
that you really
where
thought
I think
about it.
it's going, I'm going to be so upset.
Yeah, it's
good.
not.
We'll
This
see.
is not going in a great direction.
No, it's not. While he didn't eat raw food, he did kind of have a thing for very lightly cooked bacon. This guy apparently had eaten non-crispy bacon
Why?
his entire life. And this seems like a really small detail. But the doctors did note that, and we'll come back to that little note. So not able to figure out what was going on, they ordered a CT scan of his head, which is a pretty smart move. And what they found were numerous cysts deep in his brain,
Yep.
which is, in 2 words, not good.
No, that's
So
bad.
his doctors are like, okay, cysts, there's a number of things that can cause cysts, right? So it could be, first of all, it could be a genetic thing that just genetically are prone to getting cysts. And the neurology folks were like, no, we would really like to rule out an infectious disease. So we should bring the infectious disease folks into this conversation at this point. So there's a whole team of people working on this. They did all kinds of blood tests. And one of the things they'd also found out was that he had a cat. And so one of the diseases they wanted to rule out was an infection by Toxoplasma gondii, which we've talked about here on the show.
Twice.
Probably, twice.
Yeah.
It's one of the most common causes of neurological problems in the world. And it's spread through cat feces. So if you're cleaning the litter box, I should say, if you clean the litter box for your cat, there's a very high chance you have this in your body already. Doesn't always cause problems, but they wanted to rule that out, and turns out he didn't test positive for that. So like,
I do wear a mask every single time.
good. They're like, it's not that.
Woohoo.
But what did come back positive was a test for antibodies for cysticercosis. And since this was his brain, they finally knew what the correct diagnosis was. It was neurocysticercosis, which is a big, long, fancy way of saying he had tapeworms in his brain.
No.
Yeah, that's where I thought you were going.
This is where I thought it was going, and I didn't want it to go there. Why?
No one wanted it to go here, Rachel. No one wanted it to go here.
Bacon tartare, anybody?
Why?
Yeah, so if you know anything about tapeworms, though, stop and think about tapeworms for a minute, though. This doesn't make any sense, right?
No.
It's weird for them to be in your brain.
How did
and
they
let me
get
explain
there?
why. What the man was infected with was the common pork tapeworm. This is found in pork around the world, and we've talked about it before on this show. It's relatively uncommon in the U.S. because of our great food safety standards, but it can be out there. And like I said, this man was rather fond of barely cooked bacon, which seriously, as a bacon lover, I take offense at that and I find it nasty. You got to render that fat, people, with heat, and that's what makes it truly delicious.
Crispy
Fully cook your bacon.
Agree.
If not for food safety reasons, then for taste reasons. It's the opposite of steak. Well done is an abomination in the same way that undercooked bacon is, except that eating well done steak won't kill you. It'll just make me judge you and feel sorry for your taste buds. So here's the thing. Eating undercooked tapeworm infected bacon will not give you neurocysticercosis. It can't. That's just not how it works.
Kirk, that sentence is going to stick with me for a while.
It was hard. It was hard to get out. If you eat infected pork, undercooked, or not cooked infected pork, what you get are larval cysts that were in the meat in your intestines, and you develop an intestinal tapeworm, not a brain tapeworm. That's a pretty big distinction there.
Was he snorting the bacon or something?
No.
Yeah.
Gross. No, but it's just as bad. To get neurocysticercosis, you need to ingest not the cysts from the tapeworms, but the eggs of the tapeworms. Okay? So these are two different life stages of the tapeworms. If you ingest the eggs, they don't attack the digestive tract. They seek out your nervous system, and possibly they can make it all the way to the brain, which is what happened in this case. So where are the eggs found?
I forget what the life cycle is now.
Well, the eggs are released from tapeworms that are in the fully adult stage in the intestines. So they're found in the feces.
They're in the poop.
Infected animals.
Yeah.
They're in the poop.
They're in the poop. So this man clearly wasn't hanging out with pigs, but there is something unfortunately called auto-infection. And that's not auto as in automatic, but auto as in self.
Yeah.
He infected himself. And look, dear listeners, there is no delicate way to say this. Somehow this man ended up eating his own feces. Now, that's a rather dramatic way to put it. I don't think that was, like what's for dinner.
Not literally like taking a spoonful.
Yeah, he was not sitting down to a fecal sandwich or anything like that.
He probably went to the bathroom, didn't wash his hands well enough, and then ate something with his hands like a burger or
the doctor
bacon.
speculated it was a case of poor personal hygiene. He gave himself an intestinal parasite by eating undercooked bacon. Then he got a tapeworm, and then those tapeworms released eggs, which he probably got like on his fingers when wiping himself in the bathroom. And then, here's the important bit, failed to wash his hands after defecating.
Wash your hands, people.
He then also must not have washed his hands before eating food or a snack.
Wash your
He directly
hands.
ingested the tapeworm eggs, which led to his brain infection. So luckily for this man, they were able to give him medicine that cleared him of the infection. But I'm guessing he no longer, A, eats undercooked bacon, or B, skips the hand washing after using the toilet anymore. And you know what? That's good advice for us all.
Indeed.
So that's what I have for you this week. Brain tapeworms.
Truly.
Words to live
Hope
by.
you all enjoyed this horrifying story and reminder to wash
I didn't.
your hands and cook your bacon. If you want all the details, this was from
Wash
the
your
American
hands.
Journal of Case Reports, March 2024 edition. The paper was called Neurocysticercosis Presenting as Migraine in the United States. You're welcome.
Thanks, Kirk. That was great.
Do you mean it? Do you mean it when you say thanks? I detected a note of cynicism there.
I appreciate the public health service announcement.
Excellent. Yeah. This is look, we are not apart from nature, and that is strange to some people. Strange things happen in nature, and sometimes we are the strange thing that happens in nature, or the strange thing happens to us. So that's, yep. I hope Rachel has something nice for us. We're going to take a quick break, and hopefully it's something really, really wonderful.
I do.
See you soon.
Welcome back, everyone. Kirk, that was horrifying.
Well, you're welcome. And please.
Do have something hopefully pleasing and
Good.
happy-ish.
We need it.
Great.
We need it
It's
after
happy.
that.
Yeah. So, but to talk about it, I really need to go back a little bit. So let's talk about coral reefs for a hot second. Yes, I'm in the ocean. Ha ha ha. Surprise. So we're in Florida, which I have now been to twice. I did it all in the span of a month, and I had never been before in my life. So Florida, along the southern edge of Florida, it is one of the only places in the coastal United States that has coral reefs. Now, what's really important to note is a lot of those coral reefs, unfortunately, are not doing well.
No.
So this is to a variety of issues. Part of it is climate change and having more and more severe storms going through. Another part is just the pollution and wear that is over there that happens around that space of Florida. Another really big issue is there's been an increase of algae blooms. And part of that is because there's a keystone species, a sea urchin, that isn't really found along the coral reefs as much anymore, which takes down that algae.
I had not heard that piece of the puzzle.
So on top of that, there's more. Don't worry, we'll get back to that. Now there's also ocean acidification and temperature change and all of these issues, which are contributing to the coral reefs.
Yeah.
Rachel, this is a downer. I thought this would be a happy topic.
Well, give me some. I have to give you background so that way it can
good.
be a happy thing.
Phew, I'll be patient. Okay.
I promise.
We're coming back.
It'll be good.
Stay with us, listeners.
I mean, so you remember the urchin that I talked about, right? Yeah. So this little urchin, it was doing really well, and it was helping control a lot of the algae and the reefs in the Caribbean Ocean, or Caribbean Sea. It's not an ocean. And that it was a long-spined sea urchin. And it was doing really, really well. But then 90% of the population died off in the early 1980s.
Brutal.
So, because of that, it allowed the algae to grow a lot more, and there isn't much, like there are animals that can deal with algae. And here's the issue with algae. It's not like the blooms that happen on top of the ocean. That's not the kind of algae I'm necessarily talking about. I'm talking about the stuff that grows on the coral itself.
Sure.
So it's blocking the sun,
Right.
it's blocking any sort of filtration that the coral needs. Because
Just
corals
gumming it all
are
up,
animals.
right.
They are not just they're not like a plant or just a structure. They're a living creature that it's a kind of like what we've talked before with bryozoan. They are all growing as a colony, bigger and bigger and bigger, and they're leaving their dead cells behind them, or I guess their dead cells or whatever behind them, and then growing, to really simplify it, and then continuing to grow outwards.
Sure,
Okay.
yeah.
They're also what give coral reefs their colors and things like that. Super, super simplification.
Yeah, very much so.
Anyway. Yeah. So this algae has been sticking onto the coral and gumming everything up. It's not allowed the corals to be able to live or like filter feed like they need to, or be able to have the space to grow. So that's a problem. But there's a plan.
Oh, good.
Okay,
There's
I
a
like
plan.
plans.
There's a plan. So currently, and this actually started in 2020, and the idea it started in early 2020, but it really also started in like December. That's when the plan was revealed. Okay. This is a variety of groups that are all working together. One is a private company that is doing a lot of the work for this. But there is also work with the National Oceanic and Atmospheric Administration, the Florida Aquarium, the Coral Restoration Foundation, the Florida Department of Environmental Protection, Florida Fish and Wildlife Commission's Fish and Wildlife Research Institute, Reef Renewal, and the Nature Conservancy all partnered in on this three-phase plan to restore the reefs around the Florida Keys in southern Florida to 3 million square feet.
Okay.
Well,
Like a good start.
Okay, so they want to restore them. So it's a great spot, and this would be increasing, to give you a percentage, this would increase the amount of reef that is in Florida from the 2% that it is right now, from what it used to be, 2%, to hopefully by 2035, 25%.
Wow, that's a great goal. Yeah.
That's a wonderful goal, right? But how do they do it, right?
yes, that's what I'm wondering.
part
with
of it-
sea urchins.
Right?
I'm
Hold on to
holding
that
it.
thought. So not sea urchins, but the first phase of it is they are planting planting lab-grown coral in various in various reefs. So that way they're able to increase the coverage and help get rid of some of the nuisance algae and like choking off what's there, but refreshing some of the coral that's already there. So that way there's more of it, and there's not just, you're not trying to take back the stuff that
So
is
it's
already
like prong
potentially
one
dead.
is seed it with more
But
stuff.
Prong one, feed it with more stuff. Prong two, you got to get rid of that algae.
Yeah.
Now, those long-spined sea urchins that I mentioned, they're great, but they also remove calcium underneath when they are munching that algae. So you don't want to do that because that would damage the coral.
And there's not enough to deal with the damage. Yeah.
So what are scientists to do? They're releasing the crabs.
Okay.
All right.
Release the crabs.
Quite literally, every article I've looked at, that is part of some tagline everywhere. It's amazing. So they are raising.
They have T-shirts that say "Florida, we've got crabs."
We've got crab. Oh, that's terrible, Kirk. So they are raising Caribbean king crabs.
Okay.
Like by the thousands. And these have on their, they eat algae and they don't take away that calcium.
Nice.
So they are able to graze the algae, and actually they can graze even better than the sea urchins, because one, they don't eat that calcium underneath, but they also they're actually able to eat some of the algae that is too big or tough for the urchins to get in the first place.
Really? Okay.
Oh, great.
Yeah. So on the tips of their claws, they have like, I was looking at a picture and it looks like a horseshoe almost. It looks like curved tongs, like little tiny teeth on the edge of their claw that are ready to scrape whatever they can get.
And that doesn't hurt
and it's like a U shape.
It doesn't hurt the coral at all?
No, it just gets the algae.
Cool. Well, it sounds like there's plenty of algae.
It doesn't scrape any of the yeah. So it doesn't scrape any of the and they've been testing this, obviously.
Yeah, you don't want to just release thousands of animals. See what happens. What could possibly go wrong?
But no, the scrape actually is evolved to just harvest algae and not damage like the reef underneath and get any of the coral, because that's not what they're interested in.
Right.
And they're like voracious herbivores, so they will eat tons and tons of this algae, which is super, super cool. And is better than the sea urchins.
Cool.
The other thing, now, here's the thing. I always get nervous when people are like, "Oh, we'll just introduce this species to this area and it'll be fine."
Yep.
Right? We all get nervous. We're good, guys. So, one, these crabs don't generally get super big. They will take up to about a space of 1 kilometer when they're a full-grown adult.
Oh.
But when they're babies, they're great food for groupers and other sharks and fish. They are already part of that general ecosystem, and
they're already found
will
in that
be
area,
eaten
right?
by other predators. They're already found in that general space and area. A little further south than what they are right now, but they are still like able to be eaten by many predators. Apparently, like their babies or whatever are like candy to eat. Apparently, their babies are like candy to a lot of predators in the wild. Yeah. So like, fun little tasty.
Nice.
So, Rachel, you said that they take up to the space of 1 kilometer when they're grown. You mean like as a territory, or?
Yeah, like as a territory.
Yeah, they're not a kilometer large. That's a big crab.
Well, obviously not, but
release the Kraken.
No. No, as a territory, they take up like a little kilometer, and that's a square kilometer.
That's pretty big,
so
actually.
Not like,
I'm impressed.
It's decent size, but when you're trying to like patch up so many different isolated reefs and make more, that's not as bad. And a lot of these are going to be relatively small, so they have to get to that size in the first place.
Well, it shows that one crab can probably cover a pretty big area if that's for their territory.
Mm-hmm.
Hopefully it'll be successful.
Yeah, and they should be starting relatively soon, because the plan is to obviously have everything ready. They were starting to reintroduce corals and everything in the last couple of months and the last couple of years, but they are currently breeding the crabs and getting things ready to go so that way they can set them free into the wild, which is very, very cool.
Wow.
Yeah. So that is what I have for you both this week, for everyone. They're introducing as many as 2.8 million crabs to help restore coral.
That's a lot of crabs.
So
that's wild.
So many crabs. To give credit where credit is due, there was a great article in the Herald Tribune by Earl Kimmel, which was published in June 2022. But I also had Ocean Today, so the NOAA, the National Oceanic and Atmospheric Administration, had a wonderful article about this. Actually, they had a fun little video with the scientists actually talking about it, which was really fun. And then there was also a really good article it was called WUSIF, by Gabriel Pinos. And that was all in September of 2023. So super exciting.
Okay.
Oh, that's it.
Cool.
That's just neat. So
Nice.
thanks everyone for listening. We'll see you next week.
See you next week. Bye-bye.
Thank you then. Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.